What's up, guys? So today I'm going to quickly highlight in terms of what could cloud native really means, right? First of all, let's understand, right? Like, unlike anything else, we have been in the world of all businesses in terms of IT world, primarily having to adopt to cloud solutions because of the flexibility that we don't have to necessarily manage on premise, both from infrastructure point of view and also having to leverage the flexibility of leveraging these resources consistently, precisely, and not overuse it. Now, but on overall, if you think cloud native just means spinning up a Kubernetes cluster or even deploying on AWS, you're not alone. But you're also missing really the specific point, right? Cloud native isn't a tool, it's a vendor or even a deployment model. It's a way of designing systems. I'm pretty sure all of you are really professional in terms of how to design a system, but if you think about it, it's a way of designing systems that are resilient, observable, elastic, and decoupled by default. And in this video, I'm going to show you what could cloud native really means, right? Not just for infrastructure teams, but for engineers, architects, and the leaders for really building the systems that scale, evolve, and recover in the real world, right? Now, um, let's understand some of the common myths about cloud native, just on a high level. Cloud native is often confused with cloud hosted. Running on AWS, GCP, or Azure doesn't automatically mean you're cloud native, right? Just because you're having your services or application deployed on some of these cloud providers doesn't automatically mean you're cloud native. Most teams migrate monoliths to the cloud and call it a day. But without serverless services and some of the observable flows that you can monitor and decoupled architectures, they're just running legacy in a modern data center. And another one of the assumptions probably that you have to consider is Kubernetes or containers aren't the point. They're tools. The question is, does your system behave in a cloud native way? That is the thing. So try to understand and retrospect yourself in some of these common myths about the cloud native, right? Now, what about cloud native pillars that if you can think about some of the, if I could highlight before we get into the deep dive, one is statelessness, elasticity, observability, right? And resilience. So these are major cloud native pillars that everybody have to think through, and it is being thought through based on necessity and the complexity of the architecture. So when it comes to statelessness, services don't retain session or client state in memory or local disk, right? So now I'm trying to start these episodes from the basic point of view so that before we get into the complex concepts, we have the basics covered. And every service instance should be replaceable, restartable, right? And horizontally scalable. So what did I mean by statelessness? Services don't retain the session or the client state in memory or local disk. And every service instance should be replaceable, restartable, and it has to be horizontally scalable. And state is externalized, right? Often to cloud databases and object storage or the distributed caches like Redis or the DynamoDB, right? So why it matters? Auto scaling, zero downtime updates, container restarts are seamless. So you don't have to specifically maintain the state over there, right? So that's what is statelessness is about. That it should be irreplaceable, replaceable, restartable, horizontally scalable. Now, what do you mean by elasticity? Cloud native systems scale up and down with traffic, right? So, example, some of the, let's say, backend workers auto scale from certain number two to certain 100 pods, right? During peak traffic based on threshold that you set and the capacity that you want to monitor and based on the QPS that you monitor, the query per second, right? Using metrics driven policies, whether it is a CPU based or a queue length based or a memory based. So you scale from one size to another size of pods, let's say 2 to 200 during a peak traffic based on the configuration you set up, memory peak or queue length on CPU, right? Then elasticity applies to infra, which is a compute, and databases like read replicas, right? And even caching um, during the time of based on the TTLs, right? And even pricing point of view for serverless billing. Next is observability. How do you enforce observability? One is metrics, logs, and traces aren't bolted on later, right? They are designed in. You have to understand what are some of these factors will apply to your workflows. Example, like open telemetry traces request flow, right? From front end, gateway to microservices, and then from there to DB and to your response. What kind of response? How do you track or trace end to end? Cloud native, and we will quickly walk through any quick generic workflow in some couple of minutes. And cloud native systems use tools like Prometheus, Grafana, Datadog, and custom dashboards to track latencies, latency, errors, saturation, and throughput. Distributed tracing helps detect bottlenecks and failure points in multi-service workflows, right? Resilience. What does the fourth pillar mean here? Cloud native apps doesn't assume all services are up or fast, right? You might use like retries with exponential backoff or timeouts. And how many times you schedule a retries again matters to your design of the application, right? A number of requests that you're anticipated to get in couple of minutes or within certain like 5-10 minutes. And the bulkheads and circuit breakers, right? Example, like good example is Netflix Hystrix pattern. Message queues like Kafka or SQS decouple producers from consumers, right? And preventing any kind of a cascade failures when there's a peak traffic, right? So you can also introduce a concept of dead letter queues and retry queues, which can help you provide the durability for failed jobs or messages, right? Now, let me show you a quick diagram in terms of the walkthrough. Let's understand in terms of, having to see the breakdown. Let's break down this cloud native architecture. I'm pretty sure there are many system design examples there, but I'm giving you a generic example how this breakdown can happen. Right. I hope you're able to see my screen, right? In this diagram, if you look at user interacts with an API gateway, any application has a user to interact with, right? So the user interacts with an API gateway, and the API gateway routes requests to stateless services, which can be, let's say you have auth service to handle, which can handle the identity and access token. Front-end service, it delivers data to UI clients. And then you have backend service. You could have multiple backend services based on the workflows you are having. Like, let's say payment system have many other backend services versus the location tracking system. So the backend service processes the business logic. And then you have, so all of these services part of like when you have API gateway route, which routes requests to your stateless services. Then you have backend, which sends tasks to message queue, right? Which can be Kafka or RabbitMQ or SQS, whichever works for the architecture. Then you have a worker service, right? Which pulls from the queue and performs heavy compute or async jobs. Observability stack, right? Which tracks system health, the logs, the metrics, and the alerts. And then you have database, right? The database is accessed only by the worker or the backend, not by front end directly, right? Which is not scalable if the front end is trying to invoke database directly. So database is accessed only by the worker or backend. Data rights are isolated and protected. So this system is stateless. Services can be killed and restarted independently. You have dashboards and alerts introduced for observable pattern point of view, right? And it's resilient. right? Where you can introduce queues and retry mechanism based on the peak of the traffic and the millions of the data or the requests that you're anticipating to handle in your work flows. And it's decoupled, right? Workers offload heavy tasks here. So to recap, cloud native is not just about deploying to AWS or using containers. It's about building systems that are really designed to adapt, scale, and recover. You get elasticity without overhead, right? Observability with proper dashboards enforced and telemetry in place without bolt-ons, right? And you can plan your resilience uh, points depending on the failure points that you end up seeing in your production workflows, right? And most importantly, your platform should help you to grow your business in a resilience pattern. So the concepts that are discussed here in a basic way, what does exactly it mean when you say someone that your solution is cloud native compatible, right? So if you're an engineering manager or tech lead, right, or someone looking to scale the right way for your application, this channel is for you. So I'll start introducing again. This channel will be focusing on the cloud concepts, the AI native applications, and also a lot of leadership concepts, the frameworks that we can leverage upon. So the next video can be like, from what does it take or what does it mean from monolith to modular, right? How modular systems evolve. So don't forget to subscribe and hit the bell so you don't really miss that, right? So I'll see you soon. Thank you.